Mình có cơ hội được gặp nhau trực tiếp tại thành phố Hồ Chí Minh. Thì trong cái buổi đó thì Dương cũng đã có giới thiệu với anh chị một cái hệ sinh thái của Eaton. Bên Eaton sẽ xây dựng thứ nhất là đại diện của hãng, đó là Dương ở Việt Nam. Bên cạnh đó thì có những đối tác và có những partner của Dương sẽ cùng đồng hành với các anh chị trong suốt quá trình trải nghiệm sản phẩm, cũng như là các cái hỗ trợ đồng hành với các cái giải pháp. Có công ty PTSTS ở đây, và ở đây là có anh Võ Văn Thức. Thì song hành với đó thì từ đây đến cuối năm thì Eaton sẽ tổ chức rất nhiều các cái khóa training về các cái sản phẩm SAM liên quan đến các công tác tính toán và thiết kế phù hợp với các công ty trong các cái lĩnh vực như là tư vấn thiết kế, hoặc là các công ty về liên quan đến lĩnh vực về ngành EPC. Thì rất mong nhận được sự ủng hộ và đồng hành của các anh chị. Thì sau đây thì Dương xin giới thiệu bác Sebastian Dufresne. Sẽ có bác Sebastian thì có kinh nghiệm cũng rất là nhiều năm ở trong SAP, thì sẽ cũng truyền tải tới các anh chị một cái phần mềm về Simcap, một cái phần mềm hiện nay thì rất là phù hợp cho các cái dự án liên quan đến cái khối lượng cáp nhiều, mà chỉ cần các việc tính toán nó tối ưu sẽ giúp cho các khách hàng có thể tiết kiệm được chi phí rất là nhiều. Hey Sebastian, I think you can start from your introduction and start from your presentation. Thank you.
Okay, John, thank you very much. Good morning, everybody. John, first of all, the session we finish at 11 a.m. Vietnam time, is it correct?
Yes, correct.
Okay, okay, that's fine. Just to measure a bit my time and give some time for Q&A and all. So anyway, good morning, everyone. My name is Sebastian Dufresne. I'm regional sales manager for Eaton Sime Software. I've been with Eaton for almost 3 years now, I didn't know anything about modeling and power analysis software before that, and I've learned everything I've learned with Eaton, with my time in Eaton, and I say that because today we're going to talk about Simcap, and everything I've learned about Simcap, I've learned it with the company. And my message here, my own experience, is that it's a software that's very pleasant to use. It's quite user friendly. It's easy to self-learn from my own experience, and I'm not a design engineer, I can tell you that. So today I'd like to share about this experience with you guys. So today we'll talk mostly about Simcap, and I'll go through a very brief introduction because I have to, talking about just time and in general, and then we'll jump really 100% focus on Simcap. So I will get started without further ado. So I'll go through some slides. Of course, I want this to give you a bit of a hands-on exposure to Simcap software. So I will jump to the software from time to time, so that we can make the link between all those slides and the actual software, and how to use the actual software to model problem accurately, and do all the analysis that you may need for your project. All right, so first of all, talking about Sime. So just as a reminder, Sime was created and founded in 1986 by a few researchers from some utility company in Canada, and their vision was to create a leader company for power engineering software. So that's where Sime comes from. As we have been growing, we were acquired by Cooper in 2008. Cooper was acquired by Eaton in 2012. So we're not now part of Eaton, but still with the same DNA and 100% focus on software solution. So in Asia Pacific, we have quite a number of users, and especially talking about Simcap. Simcap's been a very, very successful product. Many utilities in Asia Pacific are using Simcap. You'll see people like Thailand PA, TNB is using in Malaysia as well. We've got the utility in Singapore as well. Most of the utilities in Australia. So really a number of users there, and also cable manufacturers, consultants. So it's been really a very very used product, very successful, a lot of installed base. And this is really due to the fact that Simcap was introduced into the market very early, very early, and we've got a lot of pioneer in the field of ampacity calculation who've been involved with that product. So Sim today, in terms of solutions, as a whole, we have power engineering software, for software. We have some engineered solution, more catered towards utility for the data integration, for server-based solution, customized web applications, things like this. And in the for software we have, where we've got Sim Power System Analysis, which is our network modeling platform and power system analysis. We've got SimGround, which is for the grounding design, SimTCC, which is for protection coordination studies, and Simcap, which we'll talk about today, which is all entirely dedicated to cable ampacity, power cable ampacity. So that's all. Yes, John, please.
Can you come back to the customer reference? I will have some brief for our own participant first.
Go ahead.
Yeah, ok. Chắc Dương xin giới thiệu lại các anh chị một chút để các anh chị hình dung về cái ngữ cảnh của phần mềm Simcap. Thì Simcap cũng là một phần trong cái hệ sinh thái của phần mềm SAM. SAM là một cái phần mềm được ra đời vào năm 1986, gọi là một trong những gọi là những phần mềm đầu tiên trên thế giới khi mà nói về phần mềm để tính toán hệ thống lưới điện. Thì đối với phần mềm SAM thì có rất nhiều các cái khách hàng trên toàn thế giới. Thì năm 2008 thì Copper mua lại, và đến năm 2012 thì Eaton mua lại Copper, thì nên SAM sẽ thuộc về Eaton chính thức là năm 2012. Thì trong khu vực Đông Nam Á này thì phần mềm Simcap cũng có rất nhiều các cái thành công và cũng đã được ứng dụng rất nhiều cho các cái công ty về điện lực, ví dụ như các cái công ty điện lực ở Thái Lan như PEA, hay là mình có TNB ở Malaysia, hay PLN Indonesia, hay là Kepo các Hàn Quốc. Thì bên cạnh đó thì cũng có các nhà sản xuất cáp như là ABB hay là LS, và cũng như các cái công ty tư vấn lớn như là Worley Paxson, họ cũng đang sử dụng phần mềm Simcap trong cái quá trình tính toán fit design hay là cái thiết kế ban đầu của họ. Thì đấy là những cái reference và Eaton và phần mềm SAM cũng rất là tự hào để giới thiệu tới các anh chị. Can you change to next slide, Sebastian? Thì đây là một cái slide rất là toàn diện về cái hệ sinh thái của SAM. Mọi người có thể SAM có những cái ứng dụng trải dài từ các lĩnh vực từ truyền tải, lĩnh vực phân phối cho đến là lĩnh vực CNI. Thì trong đó thì có phần mềm tính toán chuyên về hệ thống lưới điện, Simcap thì chuyên về tính toán phát nhiệt cáp và sắp xếp cáp, rồi sim grounding chuyên tính toán về tiếp điện cho các cái trạm điện, và cuối cùng đó là tính toán chỉnh định các thông số bảo vệ. Thì ngày nay các cái phần mềm thì đều cần phải liên đới và có làm chung trong cái hệ sinh thái, và cần có một cái sự sắp xếp và tư vấn cụ thể khi nó đi kèm với các có cần liên đới với các hệ thống như SCADA, AMI và OMS. Thì từng bước trong cái hành trình đi với anh chị thì Dương sẽ cố gắng và sẽ giới thiệu tới anh chị từng phần về các cái ứng dụng toàn bộ của SAM trong toàn bộ lưới điện. Nó sẽ đi song hành cả về phần cứng và phần mềm. Thì trong buổi ngày hôm nay thì chúng ta sẽ tập trung nhiều về Simcap, và chúng ta sẽ có cái cách nhìn, cách thức sử dụng Simcap như thế nào thì anh chị sẽ có cái nhìn rõ và cụ thể hơn. Và xong các cái chuyên đề về sau thì Dương sẽ tập trung từng các cái chuyên đề một. Okay, Sebastian, you can continue.
Thank you. Thanks, John. Okay, so that was all for the introduction about Sim. So now let's talk about Simcap and dive into this topic. So Simcap is our catalog software, which is dedicated to ampacity calculation and temperature rise. So, in brief, to talk about Simcap, what is the purpose of Simcap? Well, the purpose of Simcap is to be able to accurately model a power cable and the installation of that cable and the environment to be able to make a proper calculation of the ampacity of that cable, ampacity rating. or the temperature rise. So, you know, why this is important is because it's important to understand that Simcap is based a lot on thermal analysis. Thermal analysis, you know, we're looking at heat transfer, you know, heat transferring from a conductor, you know, which is a metallic element, which is going to have current flowing through it. And as we all know, any conductor is producing heat. You know, as long as we've got electricity through it, heat is being produced. And as we also know very well, heat is the enemy of performance for any electrical component, you know, in the field. And that's really the base of this. You know, we want to know how can we optimize the rating of our cable, you know, without reaching the temperature limit that is being set by the problem. Okay, so maybe we start with a temperature limit, and then we will look for current, or we have a current value. We want to understand what's going to be the temperature, you know, at the end of the problem. You know, Simcap can play with those two parameters. So Simcap offers what? You know, it offers a lot of modeling capabilities. To start with, detailed cable modeling, and we'll talk about that a little bit more in detail later. And also, you know, we talk about what we would call standard and non-standard installations. So here, you know, we are looking at things that, you know, are either straight coming out of IEC standards, you know, and very well described, or things that are a little bit more sophisticated, include more elements, and, you know, will fall more in the non-standard installations, leveraging things like finite element analysis. One thing about Simcap is that it's been, from the beginning, following very, very strictly, you know, whatever has been written in the IEC standards and the IEEE standards on the topic. So, you know, we have extremely good compliance with that, and everything that's been written in those standards has pretty much been implemented into Simcap. Okay, but the other good thing is that we went beyond that. Okay, because if you just look at what those IEC standards are describing, you know, it's too limited in some ways. You know, they're describing simple scenarios of, you know, some simple buried cable, maybe one duct bank, you know, like this one you see at the bottom. But today we have problems which are a lot more complex, you know, may involve different duct bank buried in different layer of soil, different thermal resistivities. It can be a lot more complex. So, you know, in Simcap, we have been introducing tools to also model those complex scenarios, but in an easy way. Okay, so that's all. The strength of Simcap is to give you a sophisticated tool, but easy to use. So in Simcap, we have different modules. You know, I mean, of course, when some customers are interested in buying some license of Simcap, depending on the projects you have, you may be dealing with different scenario. Okay, not everybody has the same type of installation. Some people deal with submarine cables, maybe. Some people deal with buried cable. Some people have duct banks. Some people have some cable in air. So, you know, there was a need to define modules dedicated to different scenario. So the base module of Simcap, pretty much we have this range of installation, which is the simplest, what we call those standard installation, okay, from directly buried to backfill, including cable in air and so on. And I'll show more in detail afterward. And then we have also plenty of add-on to either enhance the installation or the analysis, you know, whether you need to introduce cable in a tunnel like this one, or you have several layers of soils and you need some multiple duct bank and backfill capabilities, or you have large non-magnetic casing, and you can use that, multiple casing module. And for the analysis, it depends on your needs as well. Do you have need to study magnetic field, or do you have cable crossing in your installation? So, we have different modules that can help you to address different needs. So, let's just get back, a step back here. Let's take a step back and look at, what is the purpose of Simcap again? We're emphasizing on that. What is cable ampacity rating? I'm sure many of you already know, but anyway, ampacity rating. So ampacity, that's a current, okay? And what are we looking at? We're looking at what is otherwise called current carrying capacity. And really, when we look at a steady state aspect, we're looking at what is the max current that my cable can withstand before the max temperature is reached. Okay, so that's a simple problem in a way. At least it's pretty clear. We have a power cable, and we know the limit of temperature because I've got the cable manufacturer data sheet, and it tells me what is the temperature limit based on what my insulation layer or whatever is next to the conductor could withstand. And that temperature might be 90 degrees maybe. And so I have this data, and I want to know how much current I can have in my cable before reaching this. So, and sometimes I can look at the problem the other way around. Again, that's something we can do in Simcap. Occasionally, like you can see, the current value would be given. So I know, oh, that specific cable, I have to run 250 ampere inside of it, but I want to know what is the temperature distribution, okay? Temperature distribution within the cable and in the environment, because maybe my project has certain consideration. I cannot heat up, the soil around the installation too much. Okay, so that's really the main purpose of Simcap. What are the factors affecting cable ampacity? Well, mostly there are three things, okay? First of all, cable construction. As always, when you do modeling, it's a simulation, okay? It's an image, a picture of the reality. And we need that picture to be as accurate as possible if we want the solution of the problem to be accurate as well, So of course, that's where the challenge is most of the time, is getting your base element of the simulation to be accurate, okay? So the first thing you need to deal with is cable construction. In Simcap, you have all the capabilities to build your cable, single core, 3-core cables, all type of layers. You can add other layers. You can make custom material, things like that. So, there is a capability to have accurate cable model. Then the next thing is cable installation, okay? Because obviously one cable, depending on where it's being installed, will not perform the same, So if you put it directly buried in the soil, then the performance depends on thermal resistivity of that soil. But if you start to put it into, like here, a duct bank, and that duct bank is made of a material with specific thermal resistivity, then that will impact the thermal, behavior of that cable because of the surrounding. And maybe I can put something in the duct here, maybe a fluid or a solid medium, to improve the thermal behavior, the thermal performance of this installation. And that will help to eventually improve the capacity of my cable. So, this is very important also, how we install that cable, trying to model this installation as accurate as possible, in terms of dimensions, in terms of type of material. We want to make sure that it's a good picture of the problem. And then environmental conditions. This is the third very important aspect that will also affect cable ampacity. So I keep talking about soil thermal resistivity, okay? And that is very important. Thermal resistivity is really gonna condition how the heat transfer happen, Obviously, when the cable, the temperature is going up and heat is being produced, if it has a soil that has low thermal resistivity, that the heat is going to flow quickly, But if the resistivity is high, it's going to be less favorable to quick transfer of heat. So the cable will keep on heating up probably faster, all right? It's all about regulating that, temperature rise in a way. Ambient temperature is also important. Of course, if your soil here is at a high temperature, that's less good. Of course, you're gonna affect the performance of cable. So you need to look at temperature of the soil, and maybe temperature of the soil at different depths. Maybe the temperature of my soil here is 24 degrees, maybe a bit lower, 2 meters lower, it's 23 degrees, or, it depends. You have to look into that, and how you want to model your problem more accurately.
Hi Sebastian, can you come back to...
Yes, John.
Yeah,
yes.
Cái này Dương xin phép dừng một chút để giới thiệu về phần này. Thì như một số các anh chị cũng có thể đã biết, nhưng mà tổng thể thì Dương nói là có nhiều các cái chủng loại cáp các nhà sản xuất khi họ đưa ra thì họ cũng đã có trong catalog về cái nhiệt độ mà khi vận hành và cái cách sắp xếp, mà thường đa số đấy là cái cách thức lắp đặt cáp cơ bản, gọi là trong điều kiện lý tưởng và cũng như là trong cái điều kiện gọi là đầy đủ. Mà thực tế trong quá trình thực tế thì khi mà lắp đặt ở ngoài thì sẽ có rất nhiều các cái case mà các anh chị sẽ gặp, nó sẽ khác, không giống như trong catalog và cũng như là giống trong lý thuyết. Bởi vì có những lúc mình có những cái đường vòng, có những lúc mình có những cáp phải đi bắt chéo nhau, có những lúc mà cái môi chất mà mình lắp đặt cáp nó sẽ khác nhau. Thì sau khi người ta tính toán thì người ta thấy có 3 cái yếu tố mà ảnh hưởng tới cái việc mà khả năng chịu tải, khả năng phát nhiệt của cáp. Thì nó nhất đó là về cái chủng loại cáp. Thì tất nhiên trong quá trình chọn cáp mình sẽ gọi là cái số co loại cáp, nghĩa là cũng ảnh hưởng. Thì đấy là về cái từ nhà sản xuất. Thì ngay từ trong nhà sản xuất người ta cũng đã phải sử dụng phần mềm để người ta tính toán sao cho cái khoảng cái chủng loại cáp của họ có cách kết quả tốt nhất. Đến cái yếu tố thứ hai đó là cách thức lắp đặt cáp. Thì các lắp đặt cáp thì là sắp đặt theo hình thức như thế nào, theo trong ống hay là chôn trực tiếp, rồi là các cái vật liệu mà mình chôn vào như sỏi, đất sét hay là cát. Thì những quá trình đấy thì cần có một cái công cụ để giúp cho mình có thể thử nghiệm để xem là trong quá trình đấy mình có thể sử dụng sỏi hay là một số các cái môi chất khác mình có thể bơm vào trong các cái ống để tăng cái khả năng vận hành của chủng loại cát. Và cuối cùng đó là cái môi trường hoạt động. Thì cái môi trường hoạt động thì nó cũng ảnh hưởng đến từng vùng và miền, để mình biết được là cái nhiệt độ môi trường xung quanh nó là bao nhiêu, cái bức xạ của mặt trời nó là như thế nào trong khu vực đấy, rồi là cái độ ẩm khô của đất nó như thế nào. Thì khi mình nắm bắt được các cái yếu tố vận hành vậy, mình đưa vào trong một phần mềm thì từ đó mình sẽ có một kết quả tính toán về khả năng phát nhiệt cáp rất là chính xác hơn. Thì lúc đấy mình có một cái nhìn và có cái sự tính toán nó dựa trên cơ sở khoa học, và các cái này họ cũng căn cứ vào trong các cái thuật toán đã nghiên cứu rất nhiều từ lâu năm. Thì khi mà sử dụng như này thì nó sẽ tự tin hơn trong quá trình thiết kế và cũng như là đi cáp trong thực tế trong các cái dự án mà có cái khối lượng cáp rất là lớn, và càng tối ưu được cái cách thức lắp đặt thì cái hiệu quả kinh tế sẽ càng là cao. Ok, sẽ phát triển.
All right, thanks, Dong. Calculation standards and references. So that is really more for your information. Of course, it's always interesting to go back to what standards we're talking about. So you've got a few of those, IEC. So there's just strong compliance, and we're following closely all the IEC standards that have been written on the topic of Ampacity calculation. And the first one is really, the most important, one that's certainly the most leveraged and used. This IEC 6287, which as far as Ampacity rating goes, you'll hear about that a lot. And then a few others, talking about the emergency current rating and short circuit and DC resistance and so on. So, I invite you to refer to the detail of those standards if you have interest. Like any standards, they are big, thick document with many pages, so enjoy the read. And also as a reference to some IEEE standard as well, talking about standard power cable ampacity tables. And also, we have a few papers in your books that are serving as reference for some of what has been implemented in Simcap. And interestingly enough, especially for that second point, Mr. George J. Anders, who is one of the key person really, and who's been a very important contributor to this, science around the power cable ampacity calculation. He's actually the person who worked first on the engine of Simcap software, actually. So he's at the origin of the product, and he's still involved with us, with Sim, to help us to keep improving the product. So we have some very good reference and solid contribution to make sure that Simcap keeps being ahead in terms of innovation. One thing I wanted to mention here, which I think is also interesting for all the participants here to take a look at, whenever they would have the chance. One of the most recent case of validation of Simcap, because of course Simcap is a modeling software. Like any modeling software, the question is always, how accurate is the result? How accurate is this? How am I guaranteed that I'm actually calculating the right thing? And that's fair enough. This is definitely a valid question. Of course, Simcap already from the start have been validated against measurement in the field. Okay, so we already have a few utilities we've been working with in the past who have been comparing the result of Simcap with actual field measurement. Okay, so literally just checking with Simcap, what do I find current versus temperature, and in the field I actually go to that very cable and measure the temperature and look at the current value, and then that's how you can make sure that's the best way. So this has been done obviously from the beginning, but here recently, if you're familiar with the Sigray, the Sigray B156, they actually came up with a publication, which I don't think is yet officially published, but I think they are coming up with that document in the near future. And it's basically a document that discuss a set of 11 case studies, okay, that is provided where we have some medium voltage, high voltage, AC and DC cable system considered for land and submarine applications. And basically, Simcap has been benchmarked against that study done by the Sigray. All right. So, that's something to be looking for. And, I'd be more than happy to share the reference of that whenever that document would be officially published, so that I think any participant in the call may be interested in learning more about that. So, it's Sigray, so obviously that's a document you may have to buy from Sigray. It's a paying document, but it should be a very interesting study. Do you want to comment on that, Jung? Or
I think that's okay.
Okay, no problem. I thought you were unmuting yourself. No problem. All right. So, okay, let's jump off the slides a little bit for a moment, just not to get bored with PowerPoint. I'm just going to open Simcap, now, just to get a bit started with looking at the document.
Thì vừa rồi là một cái thuyết bác Sebastian muốn nói mọi người về tổng quan, nói chung là cái mindset khi người ta xây dựng phần mềm, tại sao người ta xây dựng lên phần mềm, cũng như các cái tiêu chuẩn và các cái cơ sở khoa học để người ta đưa vào trong phần mềm. Thì cái phần đầu nó cũng hơi giới thiệu lý thuyết một tí, thì sau đây thì chúng ta sẽ đi vào phần thực hành. Thì chắc là các anh chị đã cài phần mềm và kích hoạt license rồi, thì mình có thể cùng mở phần mềm lên và follow các cái bước của bác Sebastian. Các anh chị nhé.
All right. Well, in a first step, I'll just go through this, navigator screen. So when you open Simcap, and then, I plan later during the presentation to, try and show some specific example of some elements. But first, it's important to get familiar with, the interface and the different menus, because you have to get started with this. So when you open Simcap, you get this navigator that is really popping up on the screen. That's the one you find here, that open folder button. And the navigator has a few tabs, which pretty much contains all your database, okay? Database of studies, where you have all the different scenarios that you've been modeling and saving in your study. So in Simcap, how it works, we have a 2 layers system where we've got, the main folder is called the study, and the subfolders are called the executions. So you can have as many executions as you want under one study, okay, and save your different type of scenarios and anything for your project. The next tab is the cable, okay, and the cable is very important because it has the first thing you should be doing. Needless to say, if your model of cable is not there, you're not going to be able to go and start making an installation and start making an analysis. You have to start with the cable, okay? And you will see in Simcap that there are already cables in there, but they are not a complete database for all the cable in the world, for all the manufacturer in the world. That's just not feasible in a way, because there are also a lot of custom-made cable for certain projects sometimes. So, it's just something that's not been feasible so far. But there are plenty of cables here, different voltage levels, different, single core, 3 core, all kinds of cable type, which can be used as a reference. If you start with a cable and you feel like, I've got an 11 kV cable that's quite similar to that, you could use this model, duplicate it, create your own cable out of this one by modifying, or you start from scratch. But anyway, that's really the prerequisite, modeling your cable, okay? And later I'll show you one example, just to show you a bit the steps of modeling a cable. Though I'm not a cable expert and cable modeling expert, but I'll try my best to go through all the steps. The duct bank here is when you deal with duct bank, okay? And here it's really about defining the geometry of the duct bank, the size, where the ducts are. And what you see here are duct bank with rows and columns. But you can also model what we would call non-standard duct bank, where maybe you have a, one duct here, one duct here, one duct here, like a triangle shape. That's possible. You can do that. Yes.
Can I take have some minute? Trước mắt cho Dương hỏi là mọi người đã cài xong hết phần mềm chưa ạ? Các anh chị cho Dương thông tin được không ạ? Để Dương biết Dương điều chỉnh cái tốc độ của cái phần training ạ. Các anh chị đã có hết phần mềm và đã kích hoạt được license chưa ạ? Dạ rồi, cảm ơn anh Võ Bạn. Ok, Dương sẽ đợi thêm một chút để anh chị có thêm thời gian để trước khi đi sâu vào trong cái phần thực hành. Thì trong cái phần chatbox Dương có để link và Thức cũng vừa paste lại cái code cho mọi người, thì mọi người có thể vào phần start tìm license manager, sau đó thì paste cái mã activation code vào trong đó thì mình sẽ có license để sử dụng. For some people, user in English here, we also paste for the activation code in the chat box, so you can start the license manager 3.0 in your computer and then paste the activation code in the active task, and then you can start to use the software. So, okay, thank you. So I think now we. So here, Sebastian also have show you in. Yes, you can open the license manager, and in the tab registration and admin, you paste the activation code which we send you, and you can active for some duration to use the software. Rồi, nếu không có thêm phản hồi thì chắc là Dương sẽ tiếp tục với phần training nhé. Thì trong quá trình nếu có phần nào nhanh quá thì anh chị cứ nhắn vào trong chat box thì Dương sẽ điều chỉnh lại cho phù hợp. Okay, Sebastian, you can start.
All right, no problem. So again, this duct bank tab is for defining duct bank, the geometry of the duct bank. In actual fact, anything that's material, type, filling of the duct, that kind of thing, you can define it later into the installation that you design later. Job template is for the multiple duct bank module, where basically we define installation with different backfills, different duct bank, and we can save as a template to reuse in other projects. So that's exclusively for people who use the multiple duct bank module. The next three tabs, we're talking about transient analysis. Okay, and I'll comment a bit more about that later. But basically, transient analysis, we're no longer looking at steady state. Okay, steady state where we just run current in cable as long as possible until we see the temperature limit, and that's it. You know, that's steady state. We're reaching a maximum. That's our solution. But transient, we are looking at a profile over time. Okay, we're looking at what happens if my current in the cable is following a certain profile. You know, maybe the thermal behavior, you know, and the temperature will also follow a certain profile, and maybe not reach the temperature limit, or maybe reach it, but just for a short amount of time. So that's what we want to do with those. You know, we want to define in Simcap, we define shape, and shape is basically is just a profile, you know, over a certain amount of time with a per unit, you know, value, load factor, basically. And those shape can be combined, you know, in different portion to create a load profile, different load profile. As you can see at the bottom, we can see the whole, you know, picture of the load profile, depending on, you know, what you're looking at. Or it could be, so here, if we do a load profile, it will be a current profile. Okay, so I want to say what is my current through a certain cable. But as you can see, we can also do heat source, because we also want to see a problem where if we are looking at, you know, a heat source in the vicinity of the installation, maybe that heat source also has a profile. You know, it's not always 100 degrees continuously, or, you know, whatever it is. It might change over time. So, there's capability in Simcap to look at transient studies and really look at what happened if I've got a different profile over time. The Utilities tab is all about where you save your data, quite self-explanatory. Your main directory, your backup directory, if you've got any, your append, if you want to take a piece of database, put it into this one. And you can also, with that tag mode enable here, if I would click here, I have a location that appear here, this copy tagged to, and I can start selecting different elements in my database, model of cables, duct bank, and when I go there and apply, it just extracts that piece of database, not the entire database. So it's quite good to be selective. All right. So yeah.
Can you open again the, yeah, I think it is a good, I need to explain again.
Comment a bit. Okay, no problem.
Yeah, okay. Cái phần này là trước phần khi bắt đầu thì Dương cũng muốn giới thiệu mọi người về một chút về cái tổng thể, tại vì khi mà mọi người hiểu được cái cấu trúc tổ chức của sản phẩm của cái phần mềm thì cách tiếp cận nó sẽ trở nên dễ hơn. Thì trong phần mềm Simcap thì họ đã bố trí cho mọi người gần như là đã toàn bộ các ứng dụng đã nằm sẵn ở trong đó rồi. Thứ nhất là trong cái mục study, nó chính là các cái cây và các cái ứng dụng mà người ta đã gọi là có sẵn các cái ví dụ để mọi người có thể tham khảo các cái study. Đấy là cái tác đầu tiên, thì mọi người vào trong đấy mọi người có thể biết được là người ta đã sử dụng cái ứng dụng này như thế nào. Thì đấy là trong phần study. Phần thứ hai đó là phần cable. Thì trong phần cable sẽ có rất nhiều các chủng loại cáp, thì mọi người có thể vào đấy tìm các cái chủng loại cáp nào nó gần nhất với ứng dụng của mình thì nó cũng sẽ nhanh hơn. Cái phần thứ ba đó là duct bank, thì đó là cái cách sắp xếp ở trong các cái ống, thì mọi người có thể cũng vào trong đó để tìm cái cách sắp xếp cáp cho phù hợp. Rồi tiếp theo là job template, thì giống như là một cái phần các cái mẫu mà người ta đã sắp xếp và tổ chức, thì mình có thể tham khảo và lập lại. Rồi đến tiếp theo đó là phần save và phần history, thì giống như là các cái thông số để cho mô phỏng, thì mai sau mọi người có thể quay lại đây để mọi người lựa chọn các cái nguồn nhiệt cũng như là các cái cách thức vận hành tải sao cho phù hợp với thực tế của mình. Thì tại vì khi mà nói đến nhiệt thì ngoài cái phần mà yếu tố liên tục, nó cũng có cái yếu tố về tuần hoàn ngắn hạn và dài hạn. Thì khi mà mình mô phỏng, mình hiểu được cái cấu trúc tổ chức như vậy thì cái kết quả mô phỏng sẽ chính xác hơn. Và cái thư mục cuối cùng là utility, thì chính là cuối cùng mà mình có các cái mode như là enable task, nghĩa là mình có thể lựa chọn những cái database nó gần nhất với các cái ứng dụng của mình, để từ đó thì mình có thể copy và apply. Và khi mà mình lựa chọn cái mode đấy thì nó sẽ nhẹ nhàng hơn cho cái project của mình. Nghĩa là ở trong đây người ta đã để sẵn rất nhiều, gọi là rất nhiều cái ứng dụng người ta để chung, nhưng mà thực tế thì khi mà mình dùng, mình chỉ chiếm khoảng độ 5% hay 10% thôi. Nên là khi mà mình sử dụng cái tag enable, nó sẽ giúp mình cái database của mình nhẹ đi rất là nhiều và nó sẽ nhanh hơn. Mình không phải nhất thiết là copy cho toàn bộ. Thì đấy là ý nghĩa của cái phần tag cuối cùng là utility. Thì Dương cũng xin giới thiệu sơ qua để các anh chị nắm được cái cách thức tổ chức của phần mềm. Thì sau đây mình sẽ tiếp tục vào phần chi tiết. Hi Sebastian, you can continue.
Thanks, John. Okay. I'll just go back to the slide for a bit. So let's just go back to, a bit of a look at the modeling capabilities in Simcap, just to, summarize a bit. So first of all, looking at cable. Again, Simcap, very complete capabilities there. It's a system where we go layer by layer, starting from the conductor and going outside. We can model all type of material. You've got standard material, or you can do custom material, and then plenty of different values, parameters can be customized, or even the software has in a few places automatically suggested values based mostly on the IEC standards, because in the IEC standards, even for specific materials, you find already defined values actually that can be used. And so, this is very complete. We even added in some of the recent versions the capability to add more non-magnetic layers. So, you know, for example, some of the cables that some of our users had add more than those typical layers that we normally see in most of the cables. So, you know, they had some additional tapes, additional, you know, small layers. So we have the capability now to put even more additional layers. So really very complete capability there. So again, we can do a single core cable, can do 3-core cable. We can model, you know, different type of conductor constructions, you know, stranded wires, you know, round or shaped, etc. You know, so pretty much very complete. You know, all type of cables and conductor shape and design can be modeled. And yeah, you know, in order to really show you that better, so we're now going to jump into a specific example. And before I do that, so basically the example I'm going to challenge myself to show you today is this example here. So we are looking at this, you know, single core cable, and, you know, the data sheet here. So that's data sheet from manufacturer. So the one important thing is that every manufacturer has different data sheet, has different information, okay? And sometimes they are missing information, or, you know, sometimes you may look at it and feel like, hey, this is incomplete. Some of that is not 100% clear. Of course, that's the challenge, you know, of making an accurate model, is to have accurate information to create that model. You know, of course, if the data sheet is incomplete, you're missing information. It's a bit hard because you're gonna have to make smart assumptions. Okay, and I think smart assumptions is the one way to go. So sometimes some information helps you to make assumptions about other ones. Sometimes experience helps you to make the right assumptions as well. You know, for some specific layers, for example, by experience, we have values that work most of the time, you know, and you also need to understand what really has a strong impact on the problem or not, you know, because some layers, sometimes if you're not 100% sure of the thickness, but we have a rough idea, you know, then sometimes it's not so impactful. Okay, so that being all said, let me go now into that cable. So I'll go into the cable model. Of course, I need to be armed with my data sheet of cable, you know, and when you do that, you should have it with you. And the important thing is going to be to identify layer per layer. You know, what are those layers in the cable? And the very important thing is to know which are the magnetic, and I mean the metallic layer, metallic layer, and the non-metallic layer. So if I go in the cable and I create a new cable, and I will call it cable 27 May. Actually, that's, you know, probably not the name you would want to put as a designer. You know, you probably want to say, you know, cable 15 kV aluminum. That's probably what you want to say. So, you know, I could put that 15 kV, or, you know, this is just my cable idea. Maybe in the title here, I'm going to put that, you know, 15 kV aluminum. Put as many, you know, details you want. Here in the group cable name, you can pick one of the name you create. You can type another name if you like. Okay, I will just put it in that, you know, training folder which I have. You could put comments. That's, you know, up to you. All right. So this is the first screen we get. And here, you know, it's important to look as well. You know, what kind of what kind of cable datasheet I have here. So, what I'm seeing here is, as a matter of fact, the sizes I have is more from the, it's definitely from the imperial system, not the metric. So, for that specific example, I have to change here the unit system, but that's something you can do. So, if you have a data sheet that tells you things in inches and other, more, US origin type of data, you can change the unit system. If it's metric, use metric. So here for that specific example, I use that, but the steps are the same. So, don't be too bothered by this. We're just talking about dimensions in a different unit system, but the steps to build the cable, exactly the same. All right. So first of all, okay, looking at my cable here, I've got my single core. So, that's the first thing I want to do. I want to pick here single core. And now I've got my, conductor, my insulation layer here. Okay, that's my first step. And then I want to go here and define the cable type. Okay, so I've got several selections. Actually, through the evolutions of Simcap software, some things have stayed, but really today, the advice I can give is that, except if you have a pipe type cable, which is a very, very specific type, or those LPOF, the low pressure oil filled cable. If you have one of those, select the type, accurately. If you have something that is kind of the rest, those four here, you can put other, and it sort of include everything. So it's not going to restrict you too much. So here, for me, I just select other, and that would get me going. Now, operating voltage. So, again, refer back to my data sheet. Okay, sorry, I'm going to use that. Okay, so we're talking about 15 kV. That's fine. Let's just go at just 15 kV. Okay, and then they ask me the conductor area. Okay, conductor area, which could be, square millimeter. Here is square inch. Again, refer to your data sheet. Make sure what is the unit system that you have here. Okay, so here I've got this conductor area is right here. So it's this 500 kc mil, which is that unit I want. So I can go here and I look for my unit system, and I got the area here. Okay, so that's the value. Again, just look for what's here. If it's square millimeter instead of inch, square inch, you would use the metric unit system and select the right value. Okay, so I'm already off to a good start. I've got my conductor, I've got my insulation layer, but obviously I've got more than that here. In actual fact, I see that I have a conductor, I've got a conductor shield, an insulation shield, I got concentric wires, I got a jacket. Okay, so that's 1, 2, 3, 4, 5, 6 layers, and right now I got only 2 on my model. And even more interesting, I've got insulation and conductor and insulation. Okay, so looking at my data sheet here, so basically I've got this one, the conductor, and I got the insulation. So first of all, there's something between the conductor and the insulation, which is that conductor shield. And then there is the insulation shield on top of the insulation, and then concentric wire and jacket. So do observe this, go through layer by layer, and you see the list here. First comment, sometimes the name can be a little bit different, okay? A little bit different. So for example, here, let's look, conductor shield. Do I find it? Yes, I find conductor shield. I check it here, okay, and now it's being added, okay? Then after my insulation, I got what they call here on the data sheet, insulation shield, okay? Here in Simcap, it's called insulation screen. Slight difference. Vocabulary, unfortunately, sometimes there are no standards for the exact vocabulary. But in this example, definitely that's an insulation screen we're talking about, okay? So I'm adding this one. And then after my insulation screen or shield, I've got concentric wire, which is a metallic type of layer. And it's what is described here as the copper neutral in this data sheet. All right. So let me go and add my concentric wire. Okay. We're getting there. We're getting there. And so what are we left with? We are left with the jacket. All right. So jacket, okay, all good, is right here. Okay, so at least now, as you can see, it starts to take form, take shape. At least I think I got my layers properly figured out, which is already a good start, really good start. So now I see plenty of those red circle things, which means what? Which means I have a lot of information that I haven't informed. Okay, the D is for diameter, the TH is for thickness. Okay, and I mean, obviously, if we know the thickness of one of those layers, the diameter will be automatically calculated. Or if I know the diameter, the thickness will be automatically calculated based on the previous layer. Okay, so quite often you have one or the other. Okay, and you need to inform one or the other. So, okay, let's start with the conductor first. So you see, the moment I click on this, I have this window here that pops up on the screen. So a few things to inform. All right. The first thing is the material. And here I know that this is aluminum conductor. Okay. So I will select aluminum. If you have a custom material, no problem, click custom, and you need to have the different parameters of your material. Okay, and if I click just to show you, basically you need to inform all those different material parameters and give a name, and that's your custom made material. But here we will go with aluminum because that's what we have in this problem. For the skin and proximity loss factors, again, if you know the values and you want to put a value yourself, you can. If you put program select, it will select based on what's written in the IEC for those specific known material like copper and aluminum. Okay, so for me, I will definitely just follow that, that guidance from the IEC standard. The conductor insulation system, well, here that's obviously an extruded. And the construction, based on my cable, that's stranded with a round, a round conductor type, stranded. So am I done with that? Let's see. Oh, of course, last information, diameter. So do I have the diameter? I sure hope so, because that's one of the most important information here to get me going. So diameter right here. Okay, I've got this zone of my table that give me all the diameter, and here I've been selecting this one. And we've got a minimum over insulation, max over insulation. Sometimes you have some because the design of cable, sometimes there's some variation. We would use the max, the max value here, which is 1.235. So let me just enter that, 1.235. Okay. So I'm done with this. I will now go to the next layer, which is my conductor shield. Okay. Like I said earlier, sometimes, cable manufacturer, they like to play with us and with, people in charge of doing modeling of cable, and some information is not always there. And here in that example, typically we don't find information about that that conductor shield. As a matter of fact, we do not find, but it's not unseen. Okay, it's really not unseen. That's something that happens. So in that case, from our experience, we have typical value that we would assume, and that's from experience. And honestly, for a user, any user here who is dealing with such situation, you're missing some parameters in the data sheet. I invite you to send an email to our tech support, ask some advice. What is the parameter that you should take into consideration? So we do have some advice and guidelines. Obviously, we cannot make the decision for you because there's a certain responsibility, but we have guidelines. So here, in a case like this, in inch, we would usually assume that 0.02 value. If it was metric, we assume 0.5 millimeter. So here I put the 0.02. And by the way, the material, though, I believe that information is there. If we look at the conductor shield, yeah, that's a semiconductive type of layer. So that's something that I can put here. Semiconductive screen, there you go, at the bottom. All right. So I can go to the next, and now we're getting to the insulation layer. So insulation layer here. So first of all, what is the insulation type? So if we look at this, insulation type is that TRXLPE, okay? So you've got to know your material a bit, of course, to know what this means. But basically, XLPE is a very, very standard material for insulation. But as you can see here, you've got two types. You got the unfilled and you've got the filled XLPE. And that's quite important. Some people sometimes don't know that there's a difference between the two. And the difference can be significant in terms of the thermal performance. So here in our example, we've got this TR XLPE, and TR stands for tree retardant. Okay, and tree retardant. It's the treeing effect is something that is something that can affect the degradation of the insulation material, and some cables are specially designed to restrict that effect. Okay, and I'm not going to explain all the theory of that treeing effect in insulation of cables, because that's probably quite a long topic in itself. But TR stands for tree retardant. Okay, so to delay that effect, to reduce it. So I know that XLP field is what tree retardant is. Okay, so I'm going to select this one. All right. And so now, looking at the dimension. So for the insulation, sorry, I've lost my data in this data sheet. The conductor insulation, max over insulation, over embedded jacket. Oh, hold on. XO insulation. Oh, I think I made a mistake earlier, actually. Hold on a minute. Let me go back to the conductor. Ah, sorry. I made a mistake here. Apologies. Well, I think that's what happened. You know, you do a cable modeling, you need to carefully look at the table. There are a lot of parameters. It can take some time. Once it's done, it's done. You know, but the conductor diameter is 0.789. So, you know, that was my mistake. I took this, which is actually the insulation. So never mind. You know, that's a good thing. I can go and correct. So 0.789 is the value that I had here. Okay, this one is okay. All right, yes. And so now that's the value I need to use for the insulation. So sorry, I put that as the conductor originally, and that's 1.235. All right. Okay, I'm back on track. Good. So here, and one thing to note, as you can see here, we have conductor 90 degrees. And that's the temperature limit of conductor. That's the only temperature information we have here. As you can see in Simcap, we have the max permissible for design of steady state, which is 90. So that's, you know, what we have here. That's fine. You also have transient, you know, for emergency rating. But sometimes this also is not necessarily indicated in the data sheet. So, you know, we'll use the 110 at the moment. Okay. Insulation screen, same. We don't have information here about this one. And we assume the same, you know, that 0.02 or 0.5 if we are in millimeters. The point is that those layers usually are very small and they really don't impact the result of the thermal analysis. You know, there's been a lot of studies that have been done on that. It's really not such an important parameter here. So when we don't have the data, we have those values that we typically use. Okay. Concentric wires. So we've got copper, you know, a copper neutral, and it's a round wire type. And if we look at this data sheet, the type of information we have about the concentric wires, which is here, that copper neutral, we have that size, you know, gauge 12, which here is convenient because we can just put it here and that will calculate the thickness and the diameter, you know, quite a standard size. And I can put the number of wires. Something I can do here, I think that's an information that's here, 16 wires. So I can put it here. There you go. All right, I'm pretty much almost through. So it's just my jacket, which is remaining. And then the jacket, you know, you need to look at what is the material of the jacket and, you know, put the right material. What we're interested in is, of course, the final diameter of the jacket, which is 1.55. So I'll put here 1.55 as my diameter. And here, I believe that's this, yeah, polyethylene jacket. And I'll click OK. And guess what? We have that cable modeled, you know, as accurately as we could with that information. So that's how you go about modeling cable in Simcap. All right. So I will send you this, you know, data sheet if you like to go through the steps again, you know, to try and see how you can get to the same result, and, you know, so that you can look at the parameters. More than happy to share that with you. All right, so let's get going. I still have quite a lot of things to talk about. So modeling capabilities. Now talking about, after the cable, talking about the installations. So different type of installation in reality, and they can pretty much all be, for most of them, be designed in Simcap. So first we're looking at things like trefoil formation or flat formation. If you look at directly buried cable, so we can do this kind of design. We have cable in air capabilities. For the cable in air, though, you need to watch out for the restrictions set by the IEC 6287-2-2, which has a very specific group of installation. Okay, and that's what Simcap does for cable in air. We can't do design that really go outside of that, just because the standards haven't been written on it. Okay, so that's the bit of the restrictions here. Same goes for cable on riser pole, okay, which are also cable in air type of situation. So you got the riser, which is bringing that cable up, and this can be modeled as well in the cable in air. And then installation modeling, we can do directly buried. You can see here it's directly in the soil. We can do in ducts or pipes. So here you've got a trefoil inside of a pipe, picture of what in reality that could be. You can do duct banks, which are this kind of modeling in Simcap, and that's what in reality you have. So here, a very common case of PVC ducts inside of a concrete bank, concrete duct bank. We can add backfill on top of that, like for example, here you have a duct bank, and this is the soil, the native soil, but maybe here you want to put a specific soil on top of your duct bank to improve thermal capabilities. We can do cable in casings, which could be underwater in the seabed, like kind of buried, under the layer at the bottom of the sea, or it could be in the water, hanging there. We have cable in trough, which are this kind of shallow trench, so right under the line of the soil, so not very deep. If you're not familiar with the term shallow, that means not so deep. It's really right under the soil where you're stepping. And those trough could be filled. As you can see, this one there's some sand, or unfilled. Here it's air. And these are very different scenario, because filled with something, you talk about conduction, okay, for the heat transfer is conduction here. But in air, it's convection, and that's a totally different type of equation that goes with it. So, filled and unfilled trough are different scenarios. We've got cable in tunnels capabilities, those large tunnels, which could be ventilated or unventilated, okay? Also, another possibility in Simcap is modeling heat source, heat sinks, okay? So I've got my scenario here, cable buried in the ground, but maybe I've got a pipe of cold water, nearby, or I've got a pipe of hot water, whatever that is, in the vicinity. Well, obviously this impacts the result, When it's cold, it's actually helping to cool, a little bit. But when it's really hot, so it would affect the result. Here I can get a higher current because this is providing cooling, but here my current is lower because this is, affecting the temperature of the environment. Okay, so you can model heat source in Simcap. So anything in the environment that's a heat source or heat sink, you can model it and include it in the simulation. Then, of course, as other parameter, that affect the modeling and the analysis. Things like how the cable arrangement is done, and in the cable arrangement, the bonding arrangement is something that is very very important, because as you can see, for different type of bonding, and bonding is what? Bonding is how your cable sheath is being grounded, basically. Okay, and there are different ways to do that. It could be just a single point bonding. As you can see here, it's just grounded to one end. But it could be 2-point bonding. Bonded at the two ends. It could be that, but with multiple points and cable transposition as well. So as you can see, the cable are transposed every certain lengths. So there are different scenarios, really. It depends on the type of design you want to implement. You can see there are pros and cons, obviously. Some have no standing voltage. So when we look at standing voltage, it's really a safety issue. Okay, so standing voltage can create a risk for anyone, in the vicinity. Obviously, that's a risk. But then we look also at losses, which is something that is also important when you design. You design something, you look at performance, you look at safety, you look at cost, obviously, and eventually those are real projects that will happen with a certain amount of budget as well. So, and the rule of thumb is always that the safest solution is usually the most expensive and the less, the less good performance come out of it usually. When you really take something as really safe in engineering point of view, quite often it becomes not only expensive, but also the performance is a bit restricted. I don't know. It's an observation that I think we probably make in general through any kind of design in electrical engineering or other. But here, that's also the point. When you look at those cross bonding with cable transposition, which has no standing voltage, no losses or very small losses, but that's an expensive way to design, actually, if you look at the detail of the project. So again, that's project consideration. The point in Simcap is you can model all those different bonding, and sometimes you can try one and try the other and see how it affects the performance. So now looking at analysis capabilities. So different ways to look at the analysis in Simcap. The starting point is steady state. Okay, we look at steady state. We have an initial condition, we run the current, and we go to that stable, steady condition, and we look at what's the temperature we reach, and that's pretty much it. This is steady state. Going to 100% load factor, and just looking at when do we reach that temperature limit. And in Simcap, in steady state, we have different things we can look at. We can actually reduce the load factor and put less than 100% of load factor, which they call this daily cyclic loading. So it's still a steady state, but you just reduce the value of the load factor to less than 100%. And we also have 3 different types of solution. What we call ampacity, but equally loaded or unequally loaded, and then temperature. What's the difference between those 3? Well, the temperature is easy to understand. We set the value of current. So for example, I say this cable I want 200 ampere, this cable 300 ampere, this cable 100 ampere, and I ask the software what is going to be the temperature based on all the environmental conditions and the design and stuff. And it tells me, well, temperature will be 49.1 here, 48.6 here, 40.2 here. Okay, so I'm looking for the temperature as the solution. Ampacity here, I look at the current as the solution. in two different scenarios, equally loaded and unequally loaded. What does that mean? Equally loaded means I want the same result, the same current value for my 3 cable at the end of the problem. Meaning what? Meaning here, I can see that 90 degrees, most likely the temperature limit of that cable is being reached first by this cable for 314 ampere. So because I'm in equally loaded system, I want my 2 other cable to stop at 314 ampere, same value of current, and tell me what is the temperature associated to it. Okay, so that's equally loaded. Unequally loaded, I allow different value of current. So instead of restricting it to 314 ampere here, I will allow different value of current for each system. Okay, and here what's happened is, it's a totally different result, really. So that's how I can change the different steady state solution in Simcap. And then I've got also the transient analysis, which we've talked about. Okay, and that's the kind of report we can find. So here we talk about, for example, a profile over time. So here, if this is my load profile for my circuit, time is here. And here, for example, I'm looking at what is the temperature value over time. Okay, and in the same time, what is the current value over time? And I've got this curve that can be given, and it's not a steady state. It's really saying, look, my current will not be the same over time. Maybe you're doing emergency rating. You'll have to overload a cable for a certain amount of time. Is that possible or not? Are you going to really heat up the cable too much and damage the cable? So that's probably what you would use in this kind of condition. Another thing you can look at also is temperature field calculation. So you want to know what is the impact in terms of temperature rise in my environment. How much the ground is gonna get hotter around the cables. That's something that can be done also. And again, in terms of analysis, you can complete that also with all those add-on modules that we have. If you want to enhance specific type of the analysis, get magnetic field calculation, get more cable impedance calculation, parametric studies where you change parameters and look at different results. Duct bank optimizer, you want to optimize the position of cable in duct bank. You want to get short circuit ratings. Those are things that you can do. All right. So we'll jump again to the software so that I can show you a bit of installation, modeling, and analysis. My plan is to kind of show some directly buried cable and potentially using also the multiple duct bank to see how to model something like this based on different layers of soil, different resistivity value. That's an interesting scenario to model, and look at what is steady state, what is parametric. Transient probably won't have time for that. Temperature contour reporting. So let's get to it. We'll start and we'll see how much I can show you with that. So first, when starting a new study, the software will ask you, do you want to use this study as template? You don't have to, okay? You can say no and you start from a blank sheet, start from scratch. If you want to use this one and modify it, yeah, you can. To me, I would start, from square one, and I will do a buried 27 May. And that's that's my, anyway, title 1. I don't have to put anything. Execution title is important, so that's my execution number 1. And I just put 1. You can be more detailed, obviously. So as I explained before, we have different solutions for steady state, and we could also select transient or not. Okay, I'll not select transient for now. And I will select equally loaded for now. I can change later, so it's not too important. So I'll just equally loaded, okay. And now I want to do a directly buried installation. So you can see those screenshots showing a little bit what are the possibilities. So I can see some directly buried. I can see a cable in a pipe, pipe type cable. I can add some heat source. I can do some potentially cable crossing. Anyway, I'll start with this. Environmental parameters, go through it. Of course, it's important to put the right ambient temperature, the native soil thermoresistivity, which here is put as 1, but it could be a totally different value. Okay. So you need to see about that, and consider and modify those environmental parameters. I keep the default value for now. So what do I get next? I get my cables. Well, what are the circuits I want to introduce in the design? I got standard, 1 cable, 1 phase, or I got multiple, which could be several cable for 1 phase. I'll take standard, and I will put 1 3-phase single core cable. And we'll look at a flat formation, something quite easy. I could change some of those parameters, the power factor, and so on. I'm not going to do it here. Conductor temperature, you could change the limit here as well if you want to consider a specific value. Right now, I'll leave it as 90 by default. Okay. So what happens next? My installation data here. I got those, 3 phases that were added at this place. I can go into, well, I could double click on it, or I could go into edit. If I go into edit and I select only phase A, and for example, I want to take my 25 kV cable at the top here. In the installation, you will see absolute coordinates, X and Y. The problem is I've selected only phase A. If I want a flat formation, then I will need to do phase B, and then I will need to do phase C, which is not what I want. So what is the way I can do that? Oh, and by the way, here you can change anytime the unit system. So you see it's imperial, I click on it, it becomes metric. I'll switch to metric because I'm more used to that. So here, if I select the 3-phase instead of 1, when I go to edit now, and I get again my 25 kV cable here at the top, now the installation becomes more interesting. The coordinate system is defined as a group. So I'll define my most top left cable position, which by default is phase A. That's how the software does it. You can change that. And I will put it as -0.2. And the depth, I will put it at 1 meter. And because I want flat, I will put 3 columns, 1 row. So 3 columns, 1 row. And then I need to tell the distance between the cables, which I will put as 0.2. Okay, so I got my 3 cables. All right, so this has been positioned. And this, by the way, if you're wondering, this is a drag and drop option. Okay, I can take a single core cable, bring it here, drop it here. Okay, another option. But you can also just go here, add a circuit, my single core cable circuit here, and define coordinates. Both is okay. You can do both. So Now, am I good to do a steady state? Well, if I click on the steady state, it's going to tell me no. You have to complete the specific installation data. Okay. Specific installation data, which is right here. Okay, this is installation, my cable, my coordinates. This is specific installation data. And that is all about bonding arrangement, first of all. So, is it a bonded at both ends? Is it a single bonding, etc.? So I can put single bonded. And well, I'm pretty much good to go once I've done this. Interesting point, you could change the frequency per cable. So let's say you've got a DC cable, you can put 0, that's going to consider DC. Or even if you have an AC, but different frequency, you could change the value here. Okay, if I don't change it, it keeps 60 Hertz, which is my system frequency here by default. I could change it to 50. Okay, so for example, if I go here, I click, I can change 50 Hertz, right here in the corner. And now when I go back to this, you can see 50 Hertz is the default frequency. All right, so I click on solving, and I'm gonna get that steady state result. And that's it. I got my temperature value and the current associated to it. The middle cable is the one reaching 90 degrees first, which is not surprising because it's got the impact of the two other cable. You got a report button at the bottom here. If you click on it, you could have the Simcap report viewer or the Microsoft Excel. The Simcap report viewer is a nice way to quickly see the report, which has been introduced recently. So I could put the electrical parameter, the cable input. You select what you want, you click OK, and you're gonna get that reporting coming up. There you go. Different tabs, different parameters. So it's a pretty complete reporting. All right. Takes a little bit of time to be generated. There's a lot of parameters. And once you have this, you got your electrical parameters, induced voltage, induced current, losses, steady state summary, study summary, etc. So it's a very complete reporting. All right. All right. So that is one scenario which I'm going to save for the buried. And now, if you recall here, I'm showing this, which is a type of cable, that's a trefoil, and that's pipe in trefoil, inside of a, backfill with 0.6 thermal resistivity, inside of another one with 0.9, and under another one with 1.2, which could be the native soil, or maybe here there is native soil on top. So without following this too closely, I just want to show you quickly the capability to do it with Simcap. So if I do a new study and I said, MDB test 27.5, okay. So now this time I'm going to go here on the multiple duct bank, which you can see contain all this kind of potential design. And in my example, I'm going to say I've got, let's say, 2 backfills, okay? I got one, which is, for my buried cable, one on top, and then I've got, the native soil, so just to make a simple scenario, not exactly like my drawing just now, but close. So how does this MDB module work? Here, environmental parameter, I don't touch. And here, I will want to put, so, just to show you how to do that. So here I've got trefoil, pipe in trefoil actually, it's not trefoil in pipe, it's piped in trefoil, which is important, it's different. So that's actually this one, ducts in trefoil, not pipe. So I'm gonna have one, and I'm clicking OK. So that's fine. And now I got two tabs. I've got my cable and I've got my backfills. So what do I want to do? I want to go here, first of all, and define a first backfill installation. When I go here, I have one area called B1, which is my backfill area. I can start defining it. And let's say I want to define the first layer, which is on top of my backfill with the cable inside. So it's my backfill number 1. I will start adjusting the dimension a bit. I can put 0.5 meter, on the right 0.5, and I'm gonna say it goes down to 1 meter, let's say. Okay, then I go to the next backfill. I can do B2, and I want to put it right under, and that's going to be where my cables are going to be. So right under, you can see B3 is the area I want to be. So I'm selecting B3 here, so I can define a backfill around here, and I'm going to adjust, again, left and right about the same dimension, because that's a trench, what I want to design. And it's going to go to, let's say, 1.75 meter. Okay, I apply that. Okay, I got my two backfills. And by the way, thermal resistivity of the backfill here by default has been put as 1. But if that was something like 0.9, I adjust it. And for this one, it's 1 as well. If it's something like 0.6, I adjust it. Okay, now I got 0.6, 0.9, and 1 is my native soil. So now, how about cables? Cables, I want to put them inside of this backfill, right? It's important to first select the right backfill, okay? Where do you want your cable to be? This backfill with the right frame or this one? Well, if you want this one, select this one. Then we go in here and we define, again, let's take a different cable, maybe that's 15 kV. And let's define the coordinate of the trefoil, which, as you can see, we define the center of it. So I'll put it at 0. And the depth, I'll put it somewhere here, which is a 1.5, let's say, or 1.35, more towards the middle. And here I got a duct dimension. So I can define dimension for my cables in the trefoil. You can define the diameter here, or you can use some standard size. To make my life easier, I'm going to do that. Like I took the side 3, and as you can see now, I've got those ducts, and that's what it is. Okay. So in just a few clicks, I got, 2 backfills, into the layer of native soil and my cable in ducts. And now when I go to specific installation, which I need to define, I'm going to define the bonding, which I can do, I've got different options that are available. I will just pick any of it at the moment. Duct construction, that is an important question. Is it a custom material or is it something like PVC duct in concrete or buried? I'm going to take that. PVC is quite widely used. And what's inside of my duct? Is it air? Is it water? Is it a solid duct fitting? You have the option. Okay, so here I put air, but you could change that. Okay, and now do I want to go in here and solve it? And pretty much, in very quick, few clicks, I've been able to model a reasonably complex, installation, because we've got 2 different layers of soil plus the native soil. So we have 3 different thermal resistivity. We could change also thermal resistivity inside of the duct. So, that makes the problem. If you have to do that manually and calculate manually, that is a lot of things to check. And finally, if we look at the temperature contour, well, as you can see, I've just clicked on this one here, select my different values, and I got it here. I've got my different lines of temperature around the installation, and I can just go back to my Ampacity result. Yeah. So that's all for my demonstration here. I want to leave some time, and I know the time is running fast. And I didn't have time to touch the transient 3D or the parametric study. These are things that you can discover with the trial as well. So I invite you to explore, and if you have questions, obviously, we're more than happy to help with that. All right. Jong, I'm done with my demonstration here.
Okay, let me summarize again for some people in this. Can you come back to the catalog first for the cable catalog?
Oh, sorry, the data sheet of the cable.
Yeah, okay.
Yeah, sure.
I will start from this. Tôi xin tóm tắt cái phần nội dung của cái buổi training ngày hôm nay. Thì chúng ta đã được trải qua hai phần. Phần đầu tiên đó là mô hình hóa cáp. Thì bác sĩ Bách Trương đã đi trải qua một cái hành trình để mình có thể tạo ra một cái cáp giống trong catalog. Thì điều quan trọng là thứ nhất là mình phải có catalog trong tay, thì mình xác định các cái thông số, ví dụ như là vỏ cáp, các cái lõi cáp, ví dụ như là lõi nhiều sợi hay lõi một sợi, lõi bằng nhôm hay lõi bằng đồng, rồi là chiều đường kính của các cái lớp vỏ đó. Thì trong phần mềm Simcap thì các cái đường kính hoặc là cái độ dày nó sẽ được tự động chia cho nhau. Nên là nếu trong cái cáp mà có đường kính như mọi người nhập vào, nó sẽ tự động nó sẽ ra được cái chiều dày. Hoặc trường hợp mà mình có một số cáp họ để chiều dày của từng cái lớp, thì mình đọc kỹ các cái thông số và mình bỏ vào, thì khi đó mình sẽ mô hình hóa được một cái chủng loại cáp. Và một cái tip ở trong đây chính là trong cái phần cable, nghĩa là phần đầu tiên ấy, nó sẽ có rất nhiều các cái thư viện của các cái chủng loại cáp tương tự. Thì bác Minh Trương giải thích cho mọi người đó là cách thức tổ chức từ một cái cáp mới, nhưng mà trong quá trình làm mình có thể lấy lại trong thư viện library những cái mẫu cáp mà nó phù hợp, từ đó mình có thể chỉnh sửa, giống như là mình hay dùng từ copy hay là paste, là mình chỉnh sửa từ đấy thì nó sẽ dễ và nhanh hơn. Miễn sao có một cách để kiểm tra là mình sau khi mình đã mô hình hóa được cái cáp đó rồi, thì mình thử test xem nó đúng với thông số của nhà sản xuất hay không. Khi mình test thông số tương tự giống của nhà sản xuất rồi, thì coi như là cái mô hình cáp mà mình làm ra là tương đối là đã chính xác rồi. Thì đấy là một cái tip để chia sẻ với anh chị. Đến cái bước thứ hai thì trong cái quá trình tiếp theo đó là các cái case study về cái cách thức tổ chức cáp. Thì bác sĩ Nhân cũng hướng dẫn mọi người cách mô phỏng về khi mà đồng bộ tải hoặc là tải phân bố. Thì nghĩa là có trường hợp mà mình có sự mối liên đới giữa tải và cái nhiệt độ, cũng như là khi mà mình muốn các cái phần cáp mà chịu tải như nhau thì nhiệt độ xung quanh nó như thế nào, hoặc là khi mà mình muốn giữ nhiệt độ thì các cái tải của các loại cáp sẽ phải phân đồng bộ như thế nào. Thì đó cũng là một cái flexible, một cái linh động để mình có thể áp dụng vào trong các cái bài mô phỏng của mình. Và sau đó thì sẽ có rất nhiều các cái cây liên quan đến nhiều cái cách thức lắp đặt. Thì gần như trong Simcap họ đã thiết kế và design gần như đã bao quát hết các cái ứng dụng, từ các ứng dụng chôn cáp trong dưới đất hoặc là đi trong nhiều lớp vật liệu khác nhau. Tại vì trong thực tế có những lúc mình chôn cáp trong lớp cáp rồi sỏi, rồi ở trên mình có những cái lớp nó khác, thì khi mình hiểu được cái cấu trúc tổ chức của phần mềm rồi, thì khi mình nhập các thông số vào thì mình sẽ được cái kết quả tương đối chính xác. Thì trong cái license của Dương có gửi mọi người, thì mọi người sẽ có đủ thời gian để mọi người trải nghiệm và xem cái tính năng của sản phẩm. Thì đấy là về tương tóm tắt hai cái nội dung của ngày hôm nay. Thì sau buổi này thì mọi người tiếp tục sẽ có cái thời gian trải nghiệm cái license mà activation code Dương để ở trong chat box. Và sau đây thì Dương sẽ quay lại cái phần question, câu hỏi và trả lời. Thì nếu anh chị nào mà có một câu hỏi nào nữa thì mình sẽ chat lên, thì Dương sẽ interface với Sebastian để cùng trả lời mọi người. Có những câu hỏi vì thời gian nó ngắn quá thì Dương sẽ lưu lại và sẽ liên hệ trực tiếp mọi người để cùng thảo luận rồi sau. Thì Dương sẽ bắt đầu the session question and answer. Okay, Sebastian. So firstly, we will start for the question and answer,
Yeah,
and
sure. I saw some of the question you asked.
Yes,
For
you can
example,
start.
the XLPE. Okay, I'm just gonna display this, and I'm happy to share about that.
Okay.
Sorry, went a bit further. Okay.
So
when I talk about the XLP, there was this topic about field or unfilled. All right, so it's really one specific characteristic about the material. Okay, you got to see that some of those XLP are qualified as filled and some are qualified as unfilled. The one which are qualified as filled is, you know, otherwise called with this letter TR, which can be the tree retardant. Okay, that's what it stands for. And tree retardant is basically referring to the treeing effect, okay, which is something that affects cable and can degrade the material, okay, and that is due to, you know, something that happened when, as written here, you know, the insulation is exposed to moisture and high temperature, so this treeing effect is a consequence of that, you know, and some cable are designed with a different type of this XLP, you know, a variation that's called field or tree retardant. It's a different type of, you know, a variation of that XLP that is designed so that it can prevent the treeing effect, slow it down, you know, and make sure that you prevent a fast degradation of the material. Okay, so it's one of the characteristics of the cable that can be, you know, in certain cable design. So your cable will be either with the unfilled XLP or the filled XLP. And like I was saying earlier, you know, again, this is another example of when, you know, we have a balance between trying to have a safe, you know, safe or maybe preventing longevity of the cable, but, you know, we have other impacts on performances. So, you know, when we have filled, the longevity is better, but, you know, actually unfilled, we produce more ampacity, you know, but this is a design choice, you know, do you want to care more about maintaining your cable for a long time, or you care more about really, you know, maximizing the current, you know, so you may need to look at both, you know, and compare and see eventually what is the better choice. But this is really two different characteristics. Okay, so that's, I think, one first question that I've seen. The other one you talk about.
Okay.
Yeah, sorry, go ahead.
Về cái câu hỏi mà mọi người có một anh hỏi của Dương là về TR, XLPE và phần về XLPE thì lúc bác cũng có giải thích bằng tiếng Anh rồi, thì nó cũng có cơ sở và người ta đã nghiên cứu và người ta đã đưa ra các cái giải thích. Thì sau cái câu hỏi này thì Dương sẽ gửi cái tài liệu này để anh chị nghiên cứu thêm cụ thể hơn. Thì cái này là dựa trên cơ sở ở trên mọi người có thể thấy trên màn hình, đấy là họ đã giải thích cái việc mà tại sao trong quá trình mô phỏng người ta có thể xài cái ELPE unfilled giống như là trường hợp mà chi retardant XLPE. Thì cái câu hỏi này đã đáp ứng được cái băn khoăn của anh Nghĩa chưa ạ? Rồi, ok, thì sau này mình sẽ gửi, sau buổi này mình sẽ gửi cái giải thích chi tiết mà mọi người đang thấy ở trên cái màn. Dương chưa nghe rõ, không biết anh chị có thể nói lại được không ạ? Rồi, ok, thì trường hợp đó thì mình sẽ đi qua câu hỏi thứ hai, đó là trường hợp mà cáp 3 lõi mà mình có tích hợp cáp quang thì mình có thể mô phỏng được không? Sebastian, you can come to next question about the three-course cable with the fiber optic in the center.
Oh, yeah. Okay, so as far as the thermal analysis in Simcap goes, you know, we don't see an impact of the fiber optic that would be placed in the cable in terms of ampacity performance. Okay, so that's the first thing. So when doing steady state, normally the fiber optic is not considered as a heat source or something that really is going to affect the thermal behavior. So we're not concerned about it. Okay, but now it's an interesting question, because in Simcap we also have the capability to do what we call RTTR, which is the real-time thermal rating. And this is an application where when you have the fiber optic in the cable, and this fiber optic is connected to a DTS system to measure the temperature of the cable, we can integrate the engine of Simcap into the DTS to give a real-time reading and in real-time rating of the ampacity. Okay, so basically the fiber optic does not affect the result of a steady state analysis in Simcap, but in Simcap you have the possibility to design sections placing that fiber optic at the right place in case you're dealing with this kind of real-time application. Does that make sense?
Yes, okay. I think it makes sense. Chắc là Dương giải thích câu hỏi này, tại vì thực ra thì đối với cái phần mà cáp quang thì chúng ta có thể định nghĩa rõ là cáp quang không phải là thành phần mang nhiệt, tại vì cáp quang là cáp tín hiệu, và trong cái bản thân cáp tín hiệu và không chịu mang tải về ampere hay là gì đó, mà cáp quang chỉ đơn thuần là truyền tín hiệu nên gần như nó không phải là nguồn nhiệt. Thì dẫn đến thì trong quá trình tính toán mình có thể bypass được cái phần mà cái cáp quang ở trong, nhưng miễn là mình có thể trong lúc mà phần mình vẫn phải bố trí đúng theo cơ sở của phần là cách thức lắp đặt của cáp. Nhưng bên cạnh đó thì thực ra thì cáp quang, ngoài cái cáp quang đó thì là ở trong Simcap nó cũng có một cái ứng dụng đó là gọi là real time temperature transient monitoring, thì giống như người ta cũng dùng cái cáp quang ở giữa chính cái điểm mà mình đang có cái sợi cáp quang đó, thì là để monitor cái phần nhiệt độ cho từng sợi cáp theo gọi là thời gian thực. Thì đây là ứng dụng của cái cáp quang, một số như cái ứng dụng mà người ta đã xài cáp quang. Nên là có thể nói là cáp quang thì không ảnh hưởng gì đến cái phần mà mình tính toán cái độ phát nhiệt, và thậm chí nó còn được sử dụng để giúp cho cái quá trình mà trong một số ứng dụng là để giám sát thời gian thực về cái nhiệt độ của cáp. Thế đấy là câu hỏi về mà trường hợp mà cáp quang có bị ảnh hưởng hay không. Thì thực ra thì có một số cái cáp quang này thì nó liên quan đến các cái cáp giống như là các cái số cáp ngầm hay là cáp dưới biển, hay một số cái cáp mà người ta hay đi chung giữa là cáp động lực và cáp quang ở trong đó. Thì câu hỏi này sẽ phù hợp với các cái ứng dụng như vậy, thì chúng ta có thể tin tưởng đó là trường hợp cáp quang đi vào trong đó thì không ảnh hưởng đến khả năng mang tải, không ảnh hưởng đến khả năng tính toán của phần mềm. Yeah, okay, Sebastian, you can move to next question.
Okay. In case of long cable cross-bonded more than one cycle, each cycle is not equal. Can we simulate? I'm not sure I understand this question actually. Are we talking about like spacing of cable section? I'm not sure I understand this one. Can you try and clarify it?
Có thể nhờ anh Hiếu giải thích rõ thêm về cái câu hỏi của anh được không ạ? Thì để Dương có cái giải thích ngược lại với bác Sebastian cụ thể hơn, nghĩa là cái ứng dụng anh đang dùng cross bonding nghĩa là như thế nào không ạ? Alo, anh Hiếu nghe rõ không ạ?
Is it what we're talking about here? Because here, for example, I'm in the cross-bonded configuration, and we have this parameter, the minor section lengths here, so we can specify the P and Q. So you've got this. You can define all those distances. Is it what we are talking about?
I'm trying to ask him, but he
Okay,
have not answered.
okay.
But you can still continue to discuss, to explain like this, so I can try to summarize to them.
Absolutely. Well, this, if that's a good understanding of the question, that's the answer. Is that you can not only, yes, you can do the cross bonded, and you can define user supplied P and Q value, and you can see those P and Q parameter as defined here, which is, you got the A value is that length of section, and here you got a factor Q with that factor A, and so on here for the factor P. So you have to enter the values here. So yeah. I
can I understand like the QA or the A is like a length of one cycle?
Well, yeah, and I'm not sure if length of a cycle is the right vocabulary, because I honestly I don't have that knowledge of this term, but here that's showing when the crossing of the bonding is happening, and where it's being located along the cable. So yeah, you can adjust a different lengths for that.
Dạ, ok. Thì câu hỏi này nó hơi chuyên biệt một chút, nhưng mà trên màn hình mọi người có thể thấy đó là họ cũng đã chia ra là khoảng là 3 chu kỳ, là mình có thể các cái hệ số về PQ của hai chu kỳ giống nhau, thì mình hoàn toàn có thể thay đổi và mình mô phỏng, tại vì cái này là mình mô phỏng theo từng cái phân đoạn của cáp. Ở đây ít nhất là trong cái màn hình của mình có đã được ba cái thành phần là QA, A và PA. Thế là mình đã được ba cái phân đoạn khác nhau. Thì trường hợp đến cái phân đoạn khác nhau mà hệ thống Q, P và Q khác nhau, thì mình coi như đấy là một cái phân khúc mới, và mình có thể tiếp tục mình mô phỏng theo cái chu kỳ mới. Thì nghĩa là tại vì mình đang quan sát là khả năng phát nhiệt tại từng cái section, nghĩa là từng cái mặt cắt và từng cái độ chiều dài của đoạn cáp. Thì đối với cái cách thức lắp đặt cáp PQ ở PQ1, PQ2 thì là mình có kết quả như này. Và đối với trường hợp mà PQ có hệ số khác ở phân đoạn tiếp theo thì mình tiếp tục mình mô phỏng lần thứ hai. Thì trong cái phần ứng dụng cáp thì người ta đang có cho phần mình là PQ và A. Thì nếu như theo Dương thấy thì hiện tại là đáp ứng cho giống như là một cái một cái độ dài, một cái chu kỳ cố định. Còn trường hợp mình muốn thay đổi thì coi như mình đã coi như đấy là một case study thứ hai, thì mình có thể thực hiện tiếp một bài mô phỏng thứ hai. Thì đấy là phần trả lời của bác Sebastian. Thì trường hợp anh Hiếu còn chưa thấy hỏi mà thì có thể tiếp tục để lại câu hỏi đấy vào trong cái phần forming cuối cùng của session ngày hôm nay. Thì bên đội vũ kỹ thuật của bên Dương sẽ tiếp tục trao đổi với anh để làm rõ cụ thể thêm. Nhưng về qua cái cách giải thích của bác Sebastian thì Dương hiểu là nó hoàn toàn nó có thể đáp ứng được cái nhu cầu tính toán với PQ ở hai chu kỳ khác nhau. Rồi, cảm ơn anh Hiếu nhé. Okay, so we can come to the next question about the underground cable. He said that only he want to simulate for the 5 or 6 meter from the ground. Yeah.
Well, okay, yeah, and I was ahead a bit and looking into that question. We can solve it in Simcap. Like I can run right now the underground design I've shown and put the cable at 6 meters or deeper, and I can find the solution. So honestly, what I'm missing right now is what is the standard, because to be honest, that's the first time somebody pointed out to me that there is this 3 meter restriction. So let me ask the question, please, and give you detail what is the technology that what is the technical reference for that. We can find a solution, that I can tell you. It's not a problem. You can put deeper and you'll find a solution. So I need to check what's the standard of reference, because obviously our standard of reference most of the time is IEC. So if there's such restriction on the IEC, is it that we have another paper that was written by some researcher to demonstrate that? I will need to research on it. So my apologies, but I will need to. We can find a solution. Definitely can solve it. No problem.
But in the software, we still can put 5 or 6 meter. No problem. Is correct, Sebastian?
Correct.
Yeah.
That's what
Okay. So I think
that's what I'm
that's
thinking.
Ok, cái câu hỏi thứ hai về cái tiêu chuẩn nào mà khi mình làm cho cáp từ 5 đến 6 mét thì cái này cũng là lần đầu tiên được hỏi về câu hỏi này, nhưng mà trong phần mềm thì người ta hoàn toàn người ta cũng đã có khả năng tính toán được thoải mái cái chiều sâu của cáp so với mặt đất, nên anh chị cứ tạm thời mình cứ tin tưởng mình xài vào trong phần mềm. Thì còn cơ sở khoa học về tiêu chuẩn nào thì bác sĩ Bách Chiên sẽ check và phản hồi mọi người tiếp theo về trên cơ sở khoa học cũng như cái bài báo mà cũng như là cái sự giới hạn của tiêu chuẩn IEC nếu có. Nhưng mà về phần mềm thì hoàn toàn có thể mô phỏng được với những cái case study như vậy. Okay, the last question is about how the impact of loss factor or daily loss factor to the ampacity of cable. Daily loss, the loss factor.
Daily loss factor. I'm trying to think where we have that parameter.
I think it is like the shape of the history. It is like no, it is like the variable of load during day.
Yeah, if that's what it is, you know, definitely. You probably will find information about, you know, losses in the report. So, you know, I don't know how to. I mean, I'm trying to understand how the question is turned. You have information about losses, so, you know, depending on, you know, what you're studying, is it a steady state with 100% load factor? You know, you'll find information about the losses in the report. So if I would do a sorry, I close it now and I cannot find anymore. Oh, never mind, I can just reopen that. It's got to be a, yeah, you know, if I just solve this this directly buried, very similar to what we've done. Inside the report, you will see all the loss information. So, you know, there's really one tab on the electrical that's gonna talk about losses.